just want to tell you that so we have a balance, we have cross sectional area, oil, whatever, and says the reading on the spring balance is 4.8. The length of the cylinder is 5.0. Okay, and we have also the cross sectional area. The weight of the cylinder is also given, and says when the cylinder is in equilibrium, when it is measured, explain in terms of forces acting on cylinder. So you have the weight downwards, you have to have upthrust upwards, and obviously the resultant of these two is shown by this spring balance, right? So that would create basically a tension in this. That is the reason, right? So we are saying it would be weight should be equal to the upthrust and plus the tension. So that should be the equation here. Okay, Sohail?
Yes, sir, and the part B.
Okay, so then in the part B, we need to calculate the density of the oil. Sure. So the density of the oil can be found out using, upthrust. Upthrust is equal to rho g change in volume, right? You agree to that at least, right? So now you just need rho, and to find the density, upthrust is basically if the thin wire like this shows a reading of 4.8 and the weight is like 5.3, so the upthrust is going to be equal to weight minus tension. So 5.3 minus 4.8, what you get? I think 0.5 newtons, right?
Yes.
And after that, basically the 0.5, and then you need the volume as well, because you have the cross sectional area, you have the height. So volume is area times height, so it's going to be 13 times 5, which is what, 65?
65.
Okay, 65 centimeter cube. The biggest issue is that all of these values are in SI units, but this is not in SI unit, so you got to change it. 1 centimeter is basically 10 raised to minus 2 meter square, right? Meter. So when you cube it, so basically 1 centimeter cube will be 10 raised to minus 6 meter cube. We are going to replace this, so it means it is 65 times 10 raised to minus 6 meter cube. So I'm then going to find density by 65 into 10 raised to minus 3. Okay, minus 6, sorry. Can you please do this?
Sir, इसको M और B से भी कैसे लेंगे?
No. Because M over V would you would need, like, yeah, you can do that as well. You can do that as well. You'll get the same answer actually. No, we can't do that. I'm sorry. If we do M over V, then we'll get the density of the cylinder, not the oil. We have to do this to get the density of oil. I'm sorry. You can't do that. What'd you get, Sohail? Do you understand whoever was asking me? Hello, Maham, Sultanat, Yaya, Ali, Wajia, Munim, Khatija, both Khatijas, and Aman. Okay, Umar, alright. So basically, Sohail, you do not have a calculator and you're in the class. How bad it is.
Sir, it is 794.
794. Yeah, so it's basically, it should be the correct answer. It should be the correct answer because density of the oil is around 800, so that should be fine. You can check later with the Maxim as well. All right, is it clear?
Yes, sir.
Now, I just want to tell you, if you use density mass over volume, then this density you will get of the cylinder. and that is wrong because you need density of oil. That's why you have to use rho g delta V. Okay, I hope I've answered this question.
Yes, sir, you have.
Okay, so then we are going to go to please complete your work. I believe I created the assignment for it. I don't remember creating it, but we'll do it. No worries. So the today's topic is equilibrium forces, and basically for equilibrium forces there are two conditions. The first condition is that the sum of all forces must be equal to 0. The other condition is that the sum of clockwise moments are equal to sum of anti-clockwise moments. This about a point. Okay, so this is also known as the principle of moments. So you can remember that. And in this one basically means that all upward forces must be equal to the downward forces. That's what it means. All right. Right. Now, first part that we're going to learn is how to detect the bodies in equilibrium by just looking at them. All right. So, what exactly is the difference between equilibrium and resultant force? So, let's suppose.
Hello, sir.
Sorry.
Could you,
Yeah. Okay.
could you go off?
Yes. Sorry. Yeah.
Okay.
So, suppose there is a body that is shown to you. There is a body like this, and there are two forces on it, right? So, F1, F2. And when you used to draw vector triangle, you would pick one force and then you'd pick the other force, put the head to tail rule, and you'd realize that actually this is F1, this is F2, and then you were left with nothing, right? So what you would do was, you would actually then go from the start till end to find the resultant of these two forces. So that would be the result or the unbalanced force created because of these two. Okay. But in the same diagram, to balance this, if I add another force F3, so then the diagram would be like this: F1, F2, and F3. Same head to tail rule. But now you notice that in the first diagram, we started from here and we came here, and then you might realize that the resultant is going against the flow, which means against the movement of our vectors, right? So resultant is against movement. Then in the next one, you might see we started from here, we ended up here, and then we could actually flow in the right way. Like we could go here, here, and so it makes a complete loop. So a body's vector triangle, all right, a body's vector triangle making a complete loop is said to be in equilibrium. So this is something that you guys can see and just judge it by just looking at the diagrams. All right, so these two things are very, very important. Well, I should make them bigger, or I'll do it. Wait a second. Resize, please. I don't know how to resize. Yeah. Make it bigger. Okay, so you guys can see properly. Now, so keeping this one, it says, in this question, it says, a ball is rolling down at constant speed. Now, if there's constant speed, obviously, the forces, the net force, so the resultant forces are 0. Let me write resultant is 0. Unless it's also changing direction, that could be, a different thing. The three forces acting on the ball are weight, which is down, as we know, the contact force, which is like this, and friction, which is like this, against the movement, right? Now it says which diagram could represent these forces. Now, if I look at the first one and I start from the first force, which is weight, so obviously weight has to be down, and all of them have weight, as you can see. But in this one, when I'm going through this R, you might notice the other forces against my movement, so this can't be my answer. In this one, it is like this, which is going like this, and then it's making a whole complete loop, so this could be my answer. In this one, it is also against, can't be my answer. In this one, basically the issue is that this force can also be my answer as well, because it is making a complete loop. Now, reasonable way, we need to check the direction of R as well. So if you notice that this side should be the friction, this side should be the friction, but between this vector and this vector there is a little bit difference in slope, right? Like that. So the slope is so great that I would basically pick this answer, because it corresponds more to the resultant contact force than the D part. That's fine. Alright, is it clear? Okay. Alright, please hold on a second. Hello. Malik. Yes. Okay, I'm sorry. All right, so my bad. So I'm gonna now go to the next part, and we're gonna talk about this one. So is in this one it says a shelf PQ is attached to a vertical wall at P and supports the block and blah blah blah.
Sir, could you please explain the previous question?
Again? Okay. I'm gonna do it. So so basically what I did was the first thing you should always understand is you need to look at the diagrams and see that which diagrams have like closed loops or complete loops. Like for this one, this doesn't make complete loop because these two forces are against each other. Do you understand? So this is a resultant diagram. This is not an equilibrium diagram. So this is wrong. And then same goes for this one. You go here, you go here. This is incomplete. Like it doesn't let us go on the other side. So this is also wrong. But this one, like you can go here and then follow the path, and this will create a closed loop. And if it is creating closed loop, it means this diagram is in this body is in equilibrium in this diagram. Is it clear?
Yes.
Okay, then we also have the same thing going here. So now we have two options that we need to pick from. Okay, so then we need to see what do we do here. If you look at the forces, this shows that the force, like if this was the basically the tilt, so it shows that this is like this one, like the tilt is more like this if you notice here, and you need to find the perpendicular force basically, right? Because this is like one of them is friction, which has to be against it. In fact, I think I made a bit of mistake. It should be D. Let me see. It should be D, not C. The reason is,
Yes.
yeah, the reason is that basically the friction and this one against the slope should be 90 degrees, and it is 90 degrees from here. That's why this should be the answer, not that one. Now I just realized. Alright, Saltanat, do you understand now?
Yes, sir, I understand.
Alright, I just missed on that it should be 90 degrees, and click this by looking at it, so that's fine. I'm sorry about that, and now we're going to go to the next one. So it says that the shelf is in equilibrium, and what are the magnitudes of the horizontal and vertical components of the forces of the wall on the shelf at P, right? So we need to look at the forces here. So first of all, there is the force. It says the bar on the angle theta to the shelf exerts a force F on the shelf. Okay, so we have one of the forces like this, one of the forces like this, one of the force like this. This force will have two components, one upwards, one towards the right. Okay, now the upward component that you see, this angle has to be the same angle as this angle. Do you agree?
Yes.
Which means that this would be F cosine theta, and this will be F sine theta. Laiba is in today or no?
Yes, sir, I'm here.
Laiba, do you understand Laiba?
Yes, sir.
Okay, good. All right. So then, if you notice that there are two upward forces, and there one upward force and two downward forces, which makes the resultant force to be WS and WB added up and minus sine theta. So either this answer is correct or this answer is correct. Do you guys understand that? This answer is absolutely wrong because cos theta.
How did you get that?
I got it because the sine theta is a vertical force. You can only add or subtract a vertical force with vertical forces. You can't add cos theta with them. You get it?
Yes.
Alright. So then the next thing we're going to do is we should understand that it says that the next, it says what is the horizontal component. So our horizontal component is the only component which is cos theta. This should be the answer. Is it clear?
Yeah.
So this is like you're adding the same thing, you're doing upward forces equal to downward forces, and that would get you the right answer. That's how you do it. All right. Okay. Then going to this one, this is a very similar question. So I expect you guys would be able to do it. It's basically the same thing. All right. You will be able to do it. Don't worry. And then we are gonna go towards this one, and this is also the same kind of question that we've just done. So I also expect you guys to do it, because you just need to create like the weight, and then the chain is pulling with the tension, cable has a tension as well. And obviously then you have to check which diagram makes the right flow, right? And already if I can see that, I can see that there is one correct answer, that is C already, right? And do you guys know which answer would that be? So let's do it right now.
See?
C. C says the tension is not, yeah, but the tension in the chain, it shows that it is this way. It's not be pulled. And how is it that tension was it at an angle and now it is completely horizontal? That's not possible, right?
It's A.
It is A. The reason is, now let me just show you this. For this one, you guys first check whether it makes a flow. Yes, it does make a flow, so it has to be in equilibrium. The tension in this cable is upwards like this. The tension in this one is like this, and the weight has to be down. So this all the right things are checked here. In this one, it shows the tension is down. Tension is a pulling force, so it means this object is being pulled by these two forces. So pulling means away from it. So you can't have like opposite tension, so that is wrong. This is why this is wrong. And then this one, these are absolutely wrong, because none of the forces are horizontal, right? So these forces cannot exist, so these are wrong. Do you guys understand that?
Yes, sir.
If you still have any confusion, do let me know. Okay, then this one I believe you will be able to do now, so homework. But now I'm going to go towards this. Now in a case if you want to check which force is like which diagram is in equilibrium, the only rule for this is that all the lines of action must meet at one point. And that is how you will be able to check. For example, in this one, I have to use a ruler for this. In the actual exam, I would use a ruler. But right now, I'm just going to make a straight line, okay, using this. So one line is this. And then for this one, it is like this. Okay, so it's approximately like this. And this one, like this. Now you notice that these two lines do not meet. So this can't be our answer. Do you guys understand this? Then same way you're going to check this one. You're going to check this one. And you're going to check this one. Again, the problem with these diagrams are that the lines do not intersect at one point. So this is also wrong. Then I'm going to check this one. And I'm going to check this one. Oh. And this one. What do you guys say? Do you think it's in equilibrium?
Yeah.
Of course
Yeah.
it is in equilibrium, because it's all the lines are meeting. And we can check also the last one. Just to, tell you that I'm right. That's why. Okay, if you check it, they can never meet. They're two parallel forces. That would be wrong. Is it clear, everyone?
Yeah.
So I want you to use your ruler. Use your ruler. Alright, do not, sometimes they give very tricky diagrams, so it's better to use a ruler and then get the right answer. Anyway, so this one is the same sort of question. Can you guys tell me which is the correct one? Just by looking at it, because they've drawn the line themselves. Very nice of them. Yes, which diagram do you think is in equilibrium?
C.
C.
B. Then C.
No, B cannot be the one because they do not. These two meet here, and this meets here. This meets here. They
Yeah,
have to
so
meet.
I said B
Yeah.
then C.
Yeah, so everything else is wrong. So you understand this is a very quick way of understanding. This one, I'm going to leave this as homework, so you guys should do it now that you guys understand. Well, it's so easy that you already see the answer already. But this is a tricky one, so you use the ruler, please. Anyway, now going to the definition. Moment can be described as the force times, you can literally write times, all right? And you can write perpendicular distance from a pivot. That's what you guys need to write. So moment is written as m. It is force times perpendicular distance. The SI units for moments are Newton meter. And obviously it is a vector quantity. The reason why it is a vector quantity because either a moment can be clockwise. It could be clockwise like this, or it could be anti-clockwise like this. All right, so this is clockwise, anti-clockwise, and these are the two directions it has. That's why we consider it as a vector quantity. All right, if you have any questions, please let me know. Okay, now we're going to look at two different aspects of it, and that is what they're going to test you on. The first thing is, what is the effect of the direction of force? So first of all, I'd like to tell you that suppose all these forces are at like 5 meters from the pivot, right? And they have, all of them have the same value as well, all of them. The only difference is that this is like, this force is 60 degrees from the horizontal, that is like 90 degrees, and that is 0 degrees. Okay, so that is what we're gonna do. So first of all, let's check what happens with F1. So in F1, we're gonna say it is force times 5. Directly you're gonna get 50, I mean 500 Newton meter of the moment, right? For F2, you're gonna get, basically you need, because you need the perpendicular distance, right? So your formula should be 100 sine of 60 times t. Can somebody please find this? It will be less than 500, but I don't know what it might be. Yes, please. So it's 433 newtons, and then we got F3, and if I do 100, if I want to find sine 0, because that would give me the perpendicular times 5, what you get?
Zero.
So 0, because sine 0 is basically 0, it means that it would produce no moment at all. So then what you need to understand is that this whole thing, right? So I'm just going to write it with a different color. You will have maximum moment produced when F and D are 90 degrees. Okay, Who's in? Who just came? All right, and then you have 0 moment when force and distance are 0 degrees or parallel. So you guys should remember the effect of angle, right? Every other angle would be less. So please write it down. Let me know if you have a question.
Why don't we take cos? Yeah, sir. Why not cos?
Because if I would have taken cos, it would be wrong, because I need, for this vector, I need basically it's perpendicular of this. So perpendicular would be f2 sine theta. That's why. Do you understand? That's why. So you always try to find the perpendicular of from the distance. That's why.
Please explain this part again.
Sorry, come again.
Please explain this part again.
Okay. What I'm saying is that no matter what, if you have a pivot, the force, if the force and the distance are 90 degrees, Sohail, so you get maximum moment, as you can see from this answer as well. Do you understand?
Yes.
Obviously, if you think logically, right? If you think, you apply a force somewhere here which is at a certain angle, like 60 or anything, like theta maybe, like theta. So the perpendicular of that is going to be f sine of theta. Right now, is it clear? So sine theta, when it is like sine 90, it gives you 1, and then sine 0 gives you 0. Basically, this is what it is. Anything between 0 to 90, any angle would always give you a smaller answer because the value is smaller. Do you understand?
Yes, I understand.
Okay.
So how would we? So if we
And
the force is 100 newtons, how would we find it?
I just assumed the values that they would be 100 newton. I just assumed. No?
So let's just pick the value of F2 is 100 at a certain 5 meter.
Yeah, I just assumed these values. Alright. So if you notice this part, if you just pull the door, you're not pushing it or pulling it downwards, upwards, it would never cause the door to move. You're just pulling it this way, so how would it move? So it would create no moment. That is the reason why 0 degree has no effect on the moment. Do you understand?
Yes.
Okay, good. Now the other thing that we need to understand is the effect of perpendicular distance, because if you have the same forces, let's call this force as F1, let's call this force as F2. So when we are finding the moment for F1, we do 100 times the distance from this force till the pivot. And right now that is 2. So that's going to give me 200 Newton meter. But F2 is going to give me a moment of 100, and the perpendicular distance is from here till the pivot, right? So that would be 1 meter only, which means that it's going to be 100 only. Is it clear? So that would mean that actually the greater the distance is, for an equal moment, for an equal moment, the effort is less. So you need to put like less force to move things up if you are looking at the greater distance. All right. If you have any questions, please let me know here. Now, I hope you guys have clear understanding of what we are trying to achieve from these two factors. And if you've written it, I want to go forward. Okay. Right. So we're gonna go to the question here. And we're gonna look at first the resultant moment. So let's have a look at this question. And oh, you guys can see the screen? Hello? Did I disconnect? Oh, I guess you guys can see the screen. You guys can hear me, right?
Yes, sir.
Okay. So for this one, I just want to tell you, when you fix the pivot, let's suppose this is the pivot, just look at individual forces first. And when you're looking at individual forces, draw the directions. Now, how do you draw the direction? Let me show you. So if you imagine this force, so this force is trying to basically pull the object downwards like this. You guys agree? That would mean that actually this force is causing it to move this way, which is obviously clockwise. So with my pen, I'm going to write this force is clockwise. And now I'm going to focus on the other force only. So this force is basically trying that this plank should go this way, which makes it, a turning effect of this, which is anti-clockwise. So I'm going to write here that this is anti-clockwise. Okay. Then simply clockwise moments, I'm going to find that. And the bar is a uniform of length of 2.4, right? And it is pivoted at midpoint, which means that from the pivot, this is 1.2 meters and this is 1.2 meters. So the force is always taken from the moment is always taken from the force and the perpendicular distance. So perpendicular distance is from the pivot till the force, which is 1.2 minus 0.8, which is 0.4. So I'm gonna say that's 300 times 0.4. What you get here? Sorry? I didn't get it. I'm sorry.
120.
120. Okay. And then for the anti-clockwise moment, it's gonna be basically this distance into this force, because that's the perpendicular distance to the pivot. So it's going to be 200 times 0.8. And what is that? 160, right? So the resultant moment in this one is going to be 160 minus 120. So the result will be 40 Newton meter. And because the anti-clockwise was bigger, so we're going to write anti-clockwise. So the answer would be B. You guys get it? All right. Cool, huh? Now, keeping that in mind, I'm gonna go to the next question. Now, next question is very similar. You have a pivot here, and they have given that each arm have been 1 meter long, and then the forces are at midpoint. So I hope that you guys can do this. If you fail to do it, please do let me know. I will help you in the next class. All right?
Could you please explain this question?
This question myself?
Yes, sir.
Okay. That's not fair, but all right. So first of all, let's take our pen. So we'll start from this end, okay? And this is our pivot. just focus on this one. What do you think this will do? Don't you think it is trying to move it this way? What do you guys say?
Yes.
So that is this direction. This direction is clockwise, right? So I'm gonna put with my pen, I'm gonna say this causes it to go clockwise. Okay. Then I'm gonna stop. I'm going in this direction. Okay, I'm gonna keep going in this direction. So then this force is trying to move the whole system this way, which means that this is causing it to go this way, which is anti-clockwise. So I'm gonna put anti-clockwise like this, and this way this is also anti-clockwise, and this one is trying to put it like this, so this is clockwise. So I'm putting all the directions. This one is pulling it here, so it will cause it to go this way, which means this is clockwise. This one is trying to move, this one is trying to move it this way, which makes it anti-clockwise. This one also anti-clockwise. All right. So then the last one is this one, and obviously this is against this. This has to be anti-clockwise. Now what I'm going to do is I'm going to list them down. I'm going to write anti-clockwise and clockwise like this. It says all the lengths, like all of them are 1 meter, so the midpoints will be 0.5, right? So starting from this one, 50 into 0.5, then the other clockwise is 20, so 20 times 0.5 because it's midway, 50 times 0.5 because we're here, and then do you see any other? No. The next we're going to go to anti-clockwise. So anti-clockwise are 30 times 0.5, and then 70 times 1, and then 20 times 0.5, and then 70 times 1, we're looking at these, and 30 times 0.5. You add them all. Can you please give me the answers for both of them?
Clockwise will be 60.
Sorry?
Clockwise will be 60.
This is 60.
This is the clockwise.
So 120 total answer.
So you subtracted them?
Yes, sir.
So anti-clockwise minus clockwise is 120, and the larger one was, yeah, okay, so 120. They do not need the direction, so that's good. Very nice. All right, is it clear, everyone? Okay then. So this question I will do myself. This is actually not from the resultant, but we're going to come back later. This is a difficult question, but obviously you should try it yourself as well. That will help you determine it, and hopefully by next class we're going to finish this chapter, and then we're moving to probably work energy power. All right, so I hope you understand everything. See you soon.